So today, everyone, we're going to talk about square roots. So here I already have a definition for you all. It says a square root is a number that produces a specified quantity when multiplied by itself. So, for example, if I took the square root of 16, I would get 4, because 4 times 4 gives you 16. If I took the square root of 100, I would get 10, because 10 times 10 is 100. Here's a few other vocabulary items we'd like you to know. So right here, it says the sign square root placed before an expression to denote that the square root is to be extracted. That is called your radical sign. And lastly, down here we have the value that's inside the radical sign, the value you want to take the root of. That is always called the radicand. Don't stress too much about the vocabulary. We just wanted you to be aware of some of the terminology. So let's move on to our next page. So perfect squares. We talked a little bit about perfect squares yesterday, but for a formal definition, I just want you to know that it is. So it's a number that can be expressed by multiplying two equal integers. So remember from yesterday, we had this lovely perfect square table. So if you have different side lengths for squares to find the area, remember yesterday we told you that the formula for a square was just side times side, or in exponential form it would be s to the second power. So that's all you're doing, and like we told you yesterday, you need to memorize this perfect square table for your test. So 1 times 1 would give you 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, and so forth, 169, 196, and 225. My handwriting is really sloppy because it's hard to write on this actual program. So if you are unaware or unsure of any of these numbers I wrote down, please ask your teacher, or you could refer to your packet from yesterday. So it says find the values of these perfect squares. You could either look at your table up above or just try to figure them out. So you can think for part A, a whole number multiplied by itself will give you 4. Well, your answer is 2, because 2 times 2 gives you 4. The square root of 36 would be 6, because 6 times 6 is 36. I would like you to pause the video, try the rest of them in this section for C through P, and then play the video and you can check your answers. So here you have the answers. Remember, all you were doing here is thinking what number multiplied by itself gives you 144 or 121 and so forth. Make sure to ask your teacher if you have questions on that part, but I think you've worked with square roots and perfect squares before. Remember, when we talk about perfect squares, you're thinking about those upright squares that we talked about yesterday. So for example, if your area was 144, your side length, one way to denote it would be to take the square root of 144, which in this case would be 12. So that's how we are getting our side lengths. You're just basically taking the square root of the area to find your side length. So the next problem says find the side lengths of the perfect square with areas of the following. So that's just what I was talking a little bit about on the previous page. So all you're basically doing in this section is taking the square root of each value, because I give you the area to find your side length. You always take your square root of your area. So for example, the square root of 1 is 1. The square root of 9 is 3, and so forth, because 3 times 3 gives you 9. pause the video, try to do C through J, and then check your answers with what I have, please. So here you can see I have my answers. This was very similar to what you did on the previous page, except I didn't give you the square root. I didn't write that for you. I just told you what the area is. But like I said up here, to get your side length, all you have to do is take the square root of your area. You think what number multiplied by itself gives you 9 or 81 or 64? As always, if you're stuck on that section, raise your hand and your teacher will help you. The next thing here, it says find the missing numbers. So I could have or should have put little x's or another variable inside of here. So basically I want you to find out what x would be. So the square root of x equals 12. You have to think what number multiplied by itself would give you 12. So for example, 12 times 12 is the same as 12 squared, which is 144. So 144 would be your answer for the first one. For the next one, think 9 to the second power is 81. So that is your answer for the second one. Try to do 15 and 17. So for 15, I would think 15 to the second power would be 225. And for this last problem, 7 to the second power, or 7 times 7, is 49. So remember, all I did here, I wanted to think what number that I'm given, you just multiply it by itself, and that will give you your area. So you could think of it this way. I was given my side lengths here, and you are finding your areas. Part 4 is just a tad different. This time I give you x squared equals 121. So basically you want to think what number multiplied by itself would give you 121 or 144. Another way to think of that is to just take the square root of the value that's given. So the square root of 121 is 11. That is your answer. For the next one, the square root of 144 is 12. That is your answer because 12 to the second power, or 12 times 12, does give you 144. X squared, so if I take, x squared equals 64, so if I take the square root of 64, I get 8. And lastly, which is one I already did, the square root of 121 is equal to 11. One thing I do want to mention to you all, at the very beginning of the year we talked about opposite or inverse operations. So, if we talk about that briefly, remember opposite operations we talked about earlier in the year, where if you add or subtract something, they're opposite operations, they cancel each other out. Also, multiplying and dividing are opposite operations, so they cancel each other out. Another set of operations that are opposite or inverse would be taking the square root of a value and squaring that value. So this square root symbol and this squared symbol are opposite operations. So whenever you do the opposite of it, you're basically going to find your answer. And that's what we did in section 3 and 4. We did the opposite operations to get our value. So for this next question, I put our perfect square table on here that we had already discussed earlier in this section, because this is going to help you on the rest of this packet. That's why memorizing this table is super crucial for your success on the next test, because you are not given a calculator. So this is going to act like your cheat sheet or calculator. So the first problem says, find two consecutive whole numbers that the following lie between. So for example, the square root of 11. Look down here and see where 11 would fall down your area table. Well, 11 is between 9 and 16. So if I take the square root of 11, my side length is going to be in between 3 and 4. The next one, the square root of 230. Well, 230 is in between 196 and 225. So my side length would have to be in between 14 and 15. The square root of 180. Well, 180 is between 169 and 196. So my side length would have to be in between 13 and 14. I hope you're understanding what I did. Basically, like I said, I just found where it would fall in the area column, and then I looked under the side length column and I saw, well, what two numbers does that correspond with? I want you to try D, E, and F, pause the video, and then press play to check your answers. So for the square root of 77, you are going in between 64 and 81. So if I go a little further, it's going to be in between 8 and 9. The square root of 5 is in between 4 and 9. So my side length would have to be in between 2 and 3. And lastly, the square root of 122 is in between 121 and 144. So my side length would have to be in between 11 and 12. So all you're doing is seeing what two consecutive whole numbers the square root would lie in between. So our next set of problems say to estimate these square roots to the nearest tenth. So when you think to the nearest tenth, and you may not use a calculator, nearest tenth means 1 decimal place. So you're going to start off doing the same thing you did for section 5. So let's think. The square root of 3. Well, 3 falls in between 1 and 4. 3, so I know that it's going to be in between 1 and 2. So we are just estimating. I think the number 3 is super close to 4, so I'm not going to go at 2, but I'm going to go pretty close to 2. So on your test, I would say it's roughly 1.7, or if you put 1.8 or even 1.9 on the test, you would get credit, because on this section we are just estimating. Let's try another one. So the next one, the square root of 8. Well, just like before, 8 falls in between 4 and 9, so we know the side length is going to be in between 2 and 3. We know 8 is super close to 9, but it's not at 9, so we know we can't be at 3. So we're going to go in between 2 and 8. So on your test, if you estimated this to be about 2.8 or 2.9, you would get credit. Like I said, we are just estimating. So for the next one, the square root of 17. Well, 17 is going to be in between 16 and 25. It's super close to 16, so I'm going to go super close to 4. So if it were me on a test, I would estimate this to be about 4.1 or 4.2. The next one, the square root of 21 is in between 16 and 25 as well. So I know it's going to be in between 4 and 5. Isn't 21, I would say 21's about halfway in between 16 and 25. So I'm going to go about halfway in between 4 and 5. So on the test, if you said 4.4 or 4.5 or 4.6, you would get credit. I would like to see you say 4.6 because it's a little closer to 25 than 16. Let's try one more. The square root of 80. Well, 80 is in between 64 and 81. So I know my answer is going to be in between 8 and 9. 80 is super close to 81. So I'm going to go super close to 9. So on your test, I would probably say 8.9. If you said 8.8, you would still receive credit. I'd like you to try to do F through J on your own. pause the video, and then whenever you're done, check your answers. Remember, you only have to be in the ballpark of what I had. So if you're about 1 decimal point off, you should be okay, but if you'd like to double check, make sure to ask your teacher. So here are your answers for this section. Like I said, if you're a little off, like a decimal point off or so, that's okay, but you can always double check with your teacher. So for this section, you're technically doing the same exact thing that we did in the previous section, it just looks a little different. So it says, estimate to the nearest tenth the side lengths of squares with areas of the following. So for this one, remember, if you have a square and the area is 20, I want to think, what is this side length? Well, I'm going to take the square root of 20. And since the square root of 20 is not a perfect square, you're going to estimate on this table. So the square root of 20, 20 is pretty much really close to being halfway in between 16 and 25. So I'm going to go halfway in between 4 and 5. So I would have said roughly 4.5 on your test, give or take. The next one, 119. So to get my answer, if this is my area, I need to take the square root of 119 to find my side length. So that's going to be in between 100 and 121. It's really close to 121, so I'm going to go super close to 11. So on your test, if you said 10.8 or 10.9, that is very good and acceptable. The next one is the square root of 109. So 109, I would say, is roughly in between 100 and 121. It's a little closer to 10 than to 11. So I would say about 10.4. If you're off a tad, that's okay. The square root of 62. Well, 62 is between 49 and 64. It's really close to 64, so I'm going to go really close to 8 without going over. So I would say about 7.8, or if you had 7.9, or even 7.7, that is okay. Another one, the square root of 10. Well, 10 is in between 9 and 16. So I know my answer is going to be in between 3 and 4. 10 is much closer to 9 than it is to 16. So I'm going to roughly estimate 3.1. If you said 3.2 on the test, still that's wonderful. Why don't you try F through J on your own, pause the video, and then check your answers. So here you have your estimates. Like I said, if you're a little off in either direction, that's okay, but always check with your teacher so you know if you would get them right on your test or not. Next page, determine each square root. A lot of kids look at this problem and get very nervous because they're like, oh my gosh, I cannot do this. But actually it's quite simple. All you're going to do is take the square root of your numerator and the square root of your denominator. So let's break that up. This would be the same as writing the square root of 81 over the square root of 100. Well, I can remember from my square root table, the square root of 81 is 9, the square root of 100 is 10. 9/10 is your answer. Why don't you try to do B through D on your own and pause the video and then press play to check your work. So here are your answers for the rest of them, 9/5, 6/11, and 2/4. If you are unsure, double check with your teacher. Lastly, we're going to get into a little bit of word problems. The first problem says, Ed pours a foundation with an area of 144 square feet for a square shed. So that's the first thing I'm going to do. I'm going to draw my wonderful square shed and label my area 144. And let me fix that up a bit. There's my lovely square shed. My area is 144 square feet. It says, how many feet of lumber does Ed need to frame one side of this foundation? So all I have to know is the length of one side. Or remember, to find the length, if I'm given the area, all I have to do is take the square root of it, or think what number multiplied by itself gives you 144, which in this case it is 12 feet. Next question, how many feet will he need to frame the entire foundation? Well, this is basically asking you for the perimeter. Remember, for perimeter, you can just add up all of your sides or all of your lengths, or another way to do it is to do 4 times your length or 4 times your side. So if we know one side is 12, since this is a square, all sides are 12. So if I add it all together, or if I do 4 times 12, I will get 48 feet. I want you to try the question on Lola, pause the video, and then press play to check your answers. So for the first question, you needed to know how long will one side of the fence be? Well, if the area is 196, to find the side length, just take the square root of your area and you will get 14. And this question again was asking to find the perimeter. If we know one side of the square is 14, then all sides have to be 14. You can either add them together or multiply by 4 to give you 56. So I hope you understood this. What I need you to do now is try to take the quiz in Schoology. Please ask your teacher for help prior to taking the quiz so you understand all of this information. And we will be practicing this a bit more tomorrow as well. So thank you so much, and enjoy your day and get to work.